Hi everyone, Dr. Schmidt here. Here we are in section 7.3 talking about annual percentage yield. Now, remember we saw this equation in chapter 6, and in particular, the rate, R, was a yearly rate. That's all we've learned about up until now. And the abbreviation for yearly rate was APR, annual percentage rate. So we know what an APR is. What we're about to focus on is an APY in chapter 7. So if you start compounding your interest more than just yearly, if you compound your interest n times per year, that's why it says n periods in 1 year, well, that's great, because every time interest is compounded, your money makes more money. So now in chapter 7, we've replaced that rate, this rate right here. Let me zoom that out so you can see both of those things at once. We've replaced that rate R with APR over N. And we have an N right there. Let me tell you why. Now the R is APR divided by N, because this accounts for what I was just describing to you a moment ago, the interest being paid or being compounded n times per year. So that's even better than just once per year. So really, the equation that we learned in chapter 6 is the same as the equation we're learning here in chapter 7. It's just an upgrade. So this means a couple of things now. This means this R is the rate per period, and if n is the number of periods in a year, well, annually would mean 1 period in a year, so n equals 1. Semi-annually would mean twice per year, so n would be 2. Quarterly would mean 4 times per year, so n would equal 4. Monthly would mean, well, there are 12 months in a year, so there'd be 12 periods, so n would equal 12. Weekly, how many weeks are there in a year? Do you know? There are 52 weeks in a year, so the phrase or the word weekly would mean n would be 52. And if you have room to write that on that page, this last part, if you have room, put it on that page or put it on the next page, that's fine. If it was daily, well, there are 365 days in a year, so n would be 365. And these are the most common scenarios we are going to encounter. So in guided practice activity number 1 here, I want to start with number 3, because that is the equation here. T is in years. So if we do that, we would have P equals P0, 1 plus the APR over N to the NT. And in this problem, what are we talking about here? They gave us 8% was the APR. The initial amount was our P0, so let's make some little notes about that. That's our original amount. This is our APR. So that equation will look like, how often are we compounding? We are compounding monthly. There's that key word. So n equals 12. So we'll have 1,000 times 1 plus 8% over 12 to the 12 times t in the exponent. Make sure that 12 times t is in the exponent. Now, if you're using Excel, you can use percentages. If you're using a calculator that has a percent button, you can use percentages. Alternatively, if you're not using Excel or you're using a calculator that doesn't have a percent button, then when you do this computation, you have to convert that 8% to a decimal. So make sure you do that if you don't have the option to format the 8 as a percentage. So that's the first equation that we learned on the last page. Now, I want to go back to number 1 so that you can see how we can change this function of t, is what that's called, to be a function of m. So we used to use t as the input, years, but we can actually use m as being months as the input. So that's going to look like this, and I'll tell you why. Everything's going to be the same. So 8% or 0.08, everything will be the same. except there'll be an m in the exponent. That's the only difference. So I want you to compare, contrast that with nt. And I'm going to fill in this table in part 2 here to help you understand why these are in fact the same thing. So 12 years is equivalent to 12 months is equivalent to 1 year. 48 months is equivalent to 4 years. 6 months is equivalent to a half of a year. 3 months is equivalent to 3/12 of a year, which is 1/4. And so, if you multiply t by 12, that gives you months. That is why our nt, which is 12t, is the same as m. Do you see that? Let me make that extra obvious. M is equal to 12t. That's why part 1 and part 3 are the same. So you have options. It's most common to define your function in terms of t, but like we did up here, you could define it in terms of m, which is months, and it's almost the same thing. You just have to convert. And remember to express the 8% as a decimal if you don't have a percent formatting option. Now in part 4, we're going to do what I was just showing you. We're going to check that P12, which is where m is 12, is the same as P1, which is where t equals 1. So quick note for your notes. This expression means plug in m equals 12. That's why they wrote m equals 12 right after, to make that extra clear. And you're going to plug that into your equation from question number 1. Similarly, P parentheses 1 means plug in t equals 1 to our equation from question 3. And then we'll check and see that they are in fact the same thing. So if we do this over here, we have to take our equation up here, or this version if you prefer. So we'll have 1,000, 1 plus 8% divided by 12. Plug in 12 for the m. So 12 will go right there. Now if we go over here and plug in t for 1, right here, lo and behold, we're going to get the same thing. And that's what I was telling you a moment ago. There's a reason why these two things are equal. This number 4 here is just designed to really emphasize that fact. So 12 times 1. And yep, they're the same. That's what I've been trying to tell you. So now in part 5, we get to practice using this. I'll do the first one, part A, and you get to try parts B, C, and D. So in part A, this is our P0, our original amount. This is our APR. And we're compounding daily, so n will be 365. So that means our equation, which would ordinarily be P equals P0, 1 plus the APR divided by n to the nt power, because they said after years. So use t. Use our equation from number 3. Use t as the variable because they're talking about years. Okay, we know all these numbers. We were just talking about that. So we'll have P equals, let's see, 5,000. 1 plus, I'm going to make this percentage into a decimal because my calculator doesn't have a percent button. So I'll make that into a decimal by dividing by 100, or just moving the decimal place 2 to the left. Divide by n, we said n was 365. Raise it to the n times t power. So here's our equation. And so we did that first part. We are also supposed to find the amount after 5 years. So it's a 2-part question. So the amount after 5 years is what you get when you plug in 5 for t. The mathematical notation for that is P parentheses 5. That's the math notation for saying we're plugging in 5 for t. So I'll write that out, and then I already put it in my calculator ahead of time to keep this video as short as possible. When you put this into your calculator, you might need to add parentheses around your exponent. You might need to do that depending on which calculator you use. Now, if I do that, I get about $6,000, 261.2 5.3. And you can do the exact same process for B and for C and D. That would be great practice.